My name is Steven. I'm an MBA student from ITB School of Business and Management. It's nice to meet you, and I hope you will get something from this video. This video is about output and cost from the book written by Michael Parkin. Firms is different in many ways, from mom and pop convenience store to multinational giants producing high-tech goods. But forget about size and what they produce. All firms must decide how much to produce and how to produce it. The question is, how do firms make these decisions? Okay, to answer these questions, we are going to study the economic decisions of a small, imaginary firm called Stephen's Dolls. By studying the way a handsome owner from Stephen's Dolls copes with his firm's economic problem, we will be able to get a clear view of the problems that face all firms, even a big firm's one. Meet the owner of Stephen's Dolls, me, and meet my sweet little doll that I produce, Scrums. Before we go to the details of Stephen's Doll production, let's establish one common assumption, that all of the decisions the firms made aim at one overriding objective, maximum attainable profit. Of course you want profit and a maximum one on that. I hope you agree with me. To reach our maximum goals, there are decisions to make. And as we all know, there are small decisions and big decisions. We're gonna talk about big decisions here. I know a smart and genius person like you could take care of all small decisions and the consequences it brings. However, big decisions are vital. Once made, they are costly or even impossible to reverse. Normally, there are 4 basic big decisions to make when you start your own company. The biggest one is what industry to enter. And the second is the quantity to produce. Third, the quantities of vector of production to use or hire. And the last, the price at which to sell company's output. Let's say you already know what industry to enter. And decisions about the quantity to produce and how much you will charge the price to customer will depend on the type of market you enter. What left is number 3, the quantities of vector of production to use or hire. Or we could say how to produce a given output. Let's focus on that. To make decisions, it is important to know the concept of 2 decisions time frames. It is the short run and the long run. Okay, we're gonna start with the short run. In economic perspective, short run is a time frame in which the quantity of at least one vector of production is fixed. In Stephen's Doll, the fixed ones are capital, like machinery and shop, buildings, and land. We call the fixed vectors of production the firm's plan, and in the short run, a firm plan is fixed. To increase output in the short run, Stephen's Doll must increase the quantity of variable vector of production, which is usually labor. Short-run decisions are easily reversed. Stephen's Doll can increase or decrease its output in the short run by controlling the amount of labor it hires. Okay, now we go to the long run. In economic perspective, long run is a time frame in which the quantities of all vectors of production can be varied, or we can say that the long run is a period in which the firm can change its plan. To increase output in the long run, Stephen's Doll can choose whether to change its plan as well as the quantity of labor it hires. But the side effect of long-run decisions is that they are not easily reversed. Once a plan decision is made, the firms usually must live with it for some time. Okay, now we are ready to start, but let me give you a fair warning beforehand. The decision-making method in this video are not suitable to use to pick your future husband or wife. There are emotion in those kind of decisions, and this economic method are purely logical. Okay, here we go with the short run. To increase output in the short run, Stephen's Doll must increase the quantity of labor employed. Let's take a look first at the production schedules. There are 3 new concepts you can learn. First, it is total product. It's the maximum output that a given quantity of labor can produce. The second is marginal product. It's the increase in total product that results from a 1 unit increase in the quantity of labor employed. And then, there is an average product. It's equal to total product divided by the quantity of labor employed. Okay, let's bring it on. This is the Stephen's Doll production schedules. In this table, you can see total product, marginal product, and average product. At condition A, Stephen's Doll didn't produce anything, and so the table are empty. At condition B, Stephen's Doll hired a single labor, and company's output rise to $4 per day. The marginal product of this new higher labor is equal to $4 per additional worker, and average product is $4 per worker. At condition C, Stephen's hired 1 more labor, and the output rise to $10 per day. The output is raised by $6 per day by adding second worker. So the marginal product is 6. The average product for condition C is 10 divided by 2 labor, 5. And so on for the condition D, E, and F. If you look closely at the number in this table, you can see some pattern. As Stephen's Doll hired more labor, marginal product at first increase and then decrease. Also, average product at first increase and then decrease. To be more clear, let's look at the product curves. Product curves are graphs of the relationship between employment and the three product concepts you've just studied. Okay, this is the total product curve. As employment increases, so does the number of dolls produced. This point shows total product as the quantity of labor changed by 1 day of labor. Notice the shape of this total product curve. As employment increases from 0 to 1 and 2 workers a day, the curve becomes steeper. Then as employment increases to 3, 4, and 5 workers a day, the curve becomes less steep. I hope this part is clear enough. Let's get going to the next chart. This is the marginal product curve. This chart shows us that as Stefan's doll hire more labor, marginal product at first increase and then begin to decrease. Okay, here's the thing. The total product and marginal product curves are different across firm and type of goods. Stefan's doll product curves are different from those of Steve Jobs' Apple Inc. But the shapes of the product curves are similar because almost every production process has two features, and that is increasing marginal returns initially and diminishing marginal returns eventually. Let me explain those two terms to you. Increasing marginal returns occur when the marginal product of an additional worker exceeds the marginal product of the previous worker. In case it's still hard to understand, I will show you an example. If Stefan's doll only hire one worker, that person must learn all the aspects of doll production: modeling, cutting, material handling, sewing machine, etc. And then if Stefan's doll hire a second person, these two persons could share the job they have to do, and as a result, two workers produce more than twice as much as one. The marginal product of the second worker is greater than the marginal product of the first worker, so we could say that marginal returns are increasing. Okay, now for diminishing marginal returns. Diminishing marginal returns occur when the marginal product of an additional worker is less than the marginal product of the previous worker. This issue arises from the fact that more and more workers are using the same capital and working in the same place. For example, if 7 dolls hire a third worker, output increased but not by as much as it did when it hired the second worker. After two workers are hired, all the gains from specialization and division of labor have been exhausted. By hiring a third worker, the factory produces more dolls, but the equipment is being operated closer to its limit. There are even times when the third worker has nothing to do, because the machines are running without the need for further attention, and then the marginal returns are diminishing. This phenomenon is called the law of diminishing return. The law of diminishing return states that as firms use more of variable factor of production with a given quantity of the fixed factor of production, the marginal product of the variable factor eventually diminishes. We're going to use this law when we study a firm's cost, so let's take a look at firm's cost. We will go with the short-run cost. To increase output in the short run, 7 stall must increase the quantity of labor employed, which means that it must increase its cost. Let's take a look at it. There are 3 new concepts you can learn. We describe the relationship between output and cost by using 3 cost concepts. It is the total cost, the marginal cost, and the average cost. Total cost is the cost of all the factors of production it uses. We separate total cost into total fixed cost and total variable cost. Total fixed cost is the cost of the firm's fixed factor. The quantities of fixed factor don't change as output change, so total fixed cost is the same at all output. Total variable cost is the cost of the firm's variable factors. Example, labor wage. Total variable cost changes as total product changes. Total cost is the sum of total variable cost and the total fixed cost. Let's explore Stefan's doll cost structure. Let's say Stefan's doll rents a doll sewing machine for $25 a day. This amount is Stefan's total fixed cost, and Stefan's doll hire a worker at a wage rate $25 a day, and this cost is Stefan's variable cost. Okay, let's graph it out. In this table, you can see total fixed cost, total variable cost, and total cost. At condition A, even though Stefan's doll didn't produce anything, the total fixed cost is still in Q. It's because total fixed cost is the same at all output. There are no total variable costs, so total cost is $25. At condition B, Stefan hired 1 labor. The total fixed cost is still the same, but the total variable cost is changed. The total variable cost is $25, and so the total cost is $50 per day. At condition C, Stefan hired 2 labor. The total fixed cost is still $25. The total variable cost is $50, so the total cost is $75, and so on through condition F. If you chart it out, it will become like this. Next is a marginal cost. A firm's marginal cost is the increase in total cost that results from 1 unit increase in output. We calculate marginal cost as the increase in total cost divided by the increase in output. Okay, let's see the table and the graph. In this table, you can see an additional column of marginal cost. The increase in total cost from condition A to condition B is $25, and the increase in total output from condition A to B is $4. Dividing $25 by 4 dose, we get a marginal cost of $6.25 per additional dose, and so on to condition F. Okay, and this is the chart of Stephen's-Doll marginal cost curve. This curve is U-shaped because when Stephen's-Doll hires a second worker, marginal cost decreases, but when it hires a third, a fourth, and a fifth worker, marginal cost successively increases. And last, there is an average cost. There are three average costs. There are average fixed costs, that is total fixed cost per unit of output. There are average variable costs, that is total variable cost per unit of output, and there is average total cost, that is total cost per unit of output. The equation is like this. Okay, once again, let's grab it out. In this table, you can see an additional 3 columns of average cost. The easiest way to count for average cost is to divide it total fixed cost, total variable cost, and total cost by a company's output. That way you will get the average cost, the total fixed cost for average fixed cost, the total fixed variable cost for average variable cost, and the total cost for average total cost. After you get the average cost, you can make a chart of it, and it will become something like this. Okay, that's for the short run cost. Next is the long run cost. In the long run, a firm can vary both the quantity of labor and the quantity of capital, so in the long run, all the firm's costs are variable. Okay, there is a new kind of table, production function. The behavior of long run cost depends on the firm's production function, which is the relationship between the maximum output attainable and the quantities of both labor and capital. Let's see Stephen's-Doll production function. The table lists total product schedules for 4 different quantities of capital. Plan 1 for factory with 1 doll sewing machine. The other 3 plants have 2, 3, and 4 machines. Okay, let us look at the table. This is the production function of Stephen's-Doll. Let's see each plant's average total cost based on calculation that we learned before. This table shows us the average total cost for different plants. If we graph it out, it will become something like this. You can see that the plant size has a big effect on the firm's average total cost. There are 2 things stand out. Each short-run ATC curve is U-shaped, and for each short-run ATC curve, the larger the plant, the greater is the output at which average total cost is a minimum. Each short-run ATC curve is U-shaped because as the quantity of labor increases, its marginal product at first increases and then diminishes. You know, which short-run average cost curve Stephens operates on is depend on its plant size. But in the long run, Stephens chooses its plant size, and which plant size Stephens will choose depend on the output its plant to produce. For example, let's look at the previous graph. If Stephens plans to produce 13 dolls, the economically efficient plan to use to produce 13 dolls a day is the one with 2 machines. In the long run, Stephens chooses the plant size that minimizes average total cost. When a firm is producing a given output at the least possible cost, it is operating on its long-run average cost curve. The long-run average cost curve is the relationship between the lowest attainable average total cost and output when both the plant size and labor are varied. To be more clear, let's see the chart. The line in orange color is long-run average cost curve. The other things that we can learn from the LRC curve is the concept of economies of scale. Let's see the following graph. Economies of scale are features of a firm technology that leads to falling long-run average cost as output increase. When economies of scales are present, the LRC curve slopes downward. Economies of scales occur when percentage difference of output divided by percentage difference of input is more than 1. Beside economies of scale, there are diseconomies of scales. Diseconomies of scales are features of a firm's technology that lead to rising long-run average cost as output increase. When these economies of scales are present, the LRC curve slopes upward. These economies of scale occur when a percentage difference of output divided by percentage difference of input is less than 1. And there is one more. Between the feature of economies and diseconomies of scale, there are constant return to scale. Constant return to scale are features of a firm's technology that lead to constant long-run average cost curve as output increase. When constant return to scale are present, the LRC curve is horizontal. Constant returns to scale occur when a percentage difference of output divided a percentage difference of input is equal 1. And the last but not least from this graph is a minimum efficient scale. A firm's minimum efficient scale is the smallest quantity of output at which long-run average cost reaches its lowest level. The minimum efficient scale plays a role in determining market structure, as you will learn in perfect competition, monopoly, oligopoly, and monopolistic market. Stephen's-Doll minimum efficient scale is at $15 a day. And that's all about output and cost. Hope you enjoyed the video and get something from it. Thanks for watching and see you next time.